Today we're going to talk about how to count cells on a hemocytometer.
This device is really simple and prevents you from having to count all the cells on a plate. Plus, it stains all the cells that have died a dark blue so that you know which ones are still alive. In order to prepare samples, first we take 30 microliters of cell suspension, and this is collected in a small 1.5 or 2 ml Eppendorf tube. Then we add 30 microliters of trypan blue to make a 1-to-1 ratio of total solution. Make sure to mix the cell suspension and the trypan blue together well and take this to a hemocytometer. Here, you need to take 10 microliters of the final solution and place it on one side of the hemocytometer. And then this needs to be repeated on the other side of the hemocytometer as well. Make sure that the blue solution covers the entire area of the hemocytometer right beneath the cover slip. This cell counting device makes it really easy to count the number of dead cells and cells that are alive. Under the microscope, there are 4 4x4 squares from which we count cells. If cells are on the edges, then only those on the top and left edge were counted. Here, all the cells alive are dotted red, and those stained blue by the trypan are dotted blue. In the end, we had 42 that were alive and 4 that were dead. The counting needs to be repeated 7 more times for the other 4x4 squares on the hemocytometer. Then we can start to calculate the cell density, which is the cells per milliliter of solution. This is equal to N average divided by 0.1 microliters multiplied by 10 to the 4th times 0.1 microliters per milliliter multiplied by the dilution factor. What's the N average? That's the average number of cells that were in the 4x4 squares of the hemocytometer. Here we take only one side of the hemocytometer and calculated an average using the number of cells alive. So we had 42 plus 51 plus 38 plus 47 cells that were alive divided by 4, giving us an average of 44.5 cells. Now we can calculate the dilution factor. This is the amount by which the original cell suspension was diluted by the trypan blue. In today's case, the trypan blue and the volume of cells was equal, so we had 30 microliters of trypan blue plus 30 microliters of cells over 30 microliters of cells, giving us a dilution factor of 2. Now we can go back to our original equation to calculate the cell density. In this case, we had 44.5 cells as our N average. This is then divided by 0.1 microliters and multiplied by 10 to the 4th times 0.1 microliters per milliliter multiplied by the dilution factor of 2. In the end, if we calculate this gets us an 89 times 10 to the 4th cells per milliliter. Using the cell density, we can actually calculate the total number of cells that may have been on the plate. For example, if we have 3 ml of total cell suspension that were from the plate, then we can take the 89 times 10 to the 4th cells per milliliter and multiply it by 3 ml to get a value of 267 times 10 to the 4th cells total on the plate. We had a little less than 3 million cells total. Thank you so much for watching, and we hope you learned something today.